All right, so this video is for section 8.4 HOTS. We're going to focus on two of the harder problems, number 62, which is probably one of the hotter questions that we've done, and number 63. So we'll start off with 62. Let me share what my paper looks like here. So 62 deals with a triangle. They have an X and a Y. The X's are all the angles, the Y's are all the sides. So as you'll see, the actual angles are pretty easy. The sides take a little bit more work though. So let's start with the angles. We'll do the easy part first. So if we look at this, right? If I take angle A plus angle B plus angle C, all three angles of the triangle, I know that three angles of a triangle add to 180 degrees. So let's substitute in. Angle A is 4x plus 1. Angle B is 7x minus 1. And angle C is 3x minus 2. So those three angles together should add to 180 degrees. So 4 plus 7 plus 3, I get 14 x's. 1 minus 1 minus 2 is just negative 2. Add the 2 over, so I get 14x should equal 182. To get rid of the 14, I'm going to divide by 14. Then I'm going to ask myself, okay, how many times does 14 go into 18? That's 1, so I have 4 left over. How many times does 14 go into 42? It looks like 3 times to me. So our x is going to be 13. So I can plug those back in for angle A. That would be 4 times 13 plus 1. So 40 and 12, so 52 plus 1, 53 degrees. For angle B, I'm going to get 7 times 13 plus 1, so 70 and 21, so that's 91. That's a minus 1, sorry. 91 minus 1, which is 90 degrees. And then angle C, I'm going to have 3 times 13 minus 2, so 39 minus 2, 37. So 53, 37, and 90, they add together to 180. We're off to a good start. Now we look at the sides. Well, lucky for us, we know after we found the angles that we have a right triangle. With right triangles, we can do trig. So with trig, we have our 3 trig functions, and we can use the relationships in the sides to solve. Now in the book, it does say that we want to round to the nearest whole number for these, for at least when we find y. So when we round, we want to make sure we don't round to the end. That way it stays the most accurate. So just keep that in mind as we go through this. So if I look at angle A here, angle A, I'm just going to use sine because it's our first one. Sine would be opposite over hypotenuse. So let's set that up and see what it looks like. So if I write sine of angle A, and angle A I know is 53 degrees because we already found that. That should be equal to the opposite side over the hypotenuse, right? So we can treat this like a proportion, cross multiply. So if I cross multiply this way, I get 3y times sine of 53 minus 1 times sine of 53, which is just sine of 53. And that should be equal, if I multiply this way, to just 2y plus 2. Let's get our y's on the same side, so I'm going to subtract 2y over. So I'm going to have 3y sine 53 minus 2y. Let's add this sine of 53 over as well to get rid of it. So we're essentially trying to get the y's on the same side, everything else to the other side. So that's going to leave us with 2 plus sine of 53. Now, these two have, let's move this down here. These two have y's in common, a GCF of y. So let's pull a y out. I'm left with 3 sine 53 minus 2, and 2 plus sine 53. Now that y is being multiplied by everything in parentheses, so I can divide it over. So y should equal 2 plus sine of 53 divided by 3 sine 53 minus 2. And for that, I'm just going to type it into my calculator. And if I type it into my calculator, let's see, I believe I get 7.07. And it says round to the nearest whole number. So we'll round that to just 7. So y we're going to say is 7. So if I plug that back in, it works out pretty nice. So 7 plus 5, that should give me 12. 2 times 7 plus 2 is 14 plus 2, that's a 16. And then 3 times 7 minus 1, so 21 minus 1 should be 20, which of course the longest side is the hypotenuse. Now, this idea is going to play into number 63 as well. Number 63 says, are the values of sine and cosine for an acute triangle or a right triangle always less than 1? Values of sine and cosine for an acute angle of a right triangle always less than 1. So if we think about sine and cosine, let's just put it up here. So sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. Well, we know, and it shows it here, that the hypotenuse is always the longest side of the triangle. So both of these are being divided by the hypotenuse. If the hypotenuse is always the bigger number, well, then you have a fraction where the bigger number is in the denominator. And if you have a fraction with the biggest number in the denominator, right, that value always has to be less than 1. Right, think about it. If we have 1 over 2, 2 out of 3, 3 out of 8, right, those are all values less than 1. As long as these denominators are bigger than the numerators, right, you don't have an improper fraction, then that value will be less than 1. And with sine and cosine, because the hypotenuse is in the denominator, it has to work out that way. So are they always less than 1? Yes, right? Yes, they are. So that's it for that. More videos coming soon. Please like and subscribe. Comment if you have any questions. If you want to see any other problems, let me know. And I appreciate you guys watching. See you next time.